We are studying the first chapter, Relations and Functions. We studied about Cartesian products and relations. Today we are going to study about functions. Let us go to the definition of function. A relation f between two non-empty sets x and y is called a function from x to y if for each x belonging to x there exists only one y belonging to y such that xy belongs to f. So f is equal to, you can see it is the set of all ordered pairs, okay, for all x belonging to capital X, y belongs to y. Y is called the image of x under f. Okay, so if we will understand this better if we take an example. So here it is, x is 1, 2, 3, 4. Y is the set of natural numbers 1, 2, 3, 4 dot dot infinity. So these are the two sets, and the relation is given by y is equal to 2x. So let us write down the function. So here when you substitute x is equal to 1, you get 2. So 1, 2 is the first ordered pair. Substitute 2 here, you get 2, 4, 3, 6, 4, 8. That's all. Only 4 ordered pairs. Close the bracket. So this is a function. Why? Because every element of this x has a unique element in y. Can you see? All these elements are unique. Okay. So this is called a function. And as usual, this is the domain. X is domain. Y is the codomain. And range are the values of this images. They are called images, the y values. Okay, so 2, 4, 6, 8. Okay, this is the range. Okay, let us do some exercise sums. It will become more clear. I have also drawn this arrow diagram to make it more simple. So let us look. Here are the two sets. Let this be x and this is y. So here you can see this function from x to y. A is called the image of 1. So here all the values, elements of the set x has a unique image in y. So this is a function. Here also, see, two value elements of x has got a single image. That is okay. This is a unique image. So this is a function. But it should not be like this, that an element of x should have two images. Then it is not a function. Okay, a single image only you should have, every element. Here you can see that this element 4 does not have any image at all. So this is also not a function. So these two are not functions, but these two are functions. Let's go to the exercise. Exercise 1.3. Question 1. Let f is equal to xy such that xy belongs to n and y is equal to 2x be a relation on n. Find the domain, codomain and the range. Is this relation a function? Okay, so they have given x as n, set of natural numbers. Y also is the set of natural numbers. And the relation is given here. Y is equal to 2x. So let us now write down this function f. Okay, so here it is, substitute value of x as 1, you get 2, value of 2, value of y as 2, so 1, 2, again substitute, you get 2, 4, 3, 6, 4, 8, dot, 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 infinite ordered pairs you will get. Okay, the domain here is x, 1, 2, 3, even codomain is the set of natural numbers. Range is the set of images, so this is the image of 1, so 2, 4, 6, 8, dot, dot. Okay, yes, this relation is a function because every element of x has a unique image in y. You can take any element of this set x, you will find an image in y. So this is a function. Question 2. Let x is equal to 3, 4, 6, 8. Determine whether the relation x comma fx such that x belongs to x, fx is equal to x squared plus 1 is a function from x to n. So write down x here, n, and write down the relation. Now let us find all the images of x. So let us first take the first element, f3, substitute here. So 3 squared plus 1, that is 9 plus 1, 10. Substitute 4, the next element, you will get 4 squared plus 1, 16 plus 1, 17. Substitute 6, 6 squared plus 1, 36 plus 1, 37. 8, you will get 65. So this is the image. So what are the this function? Okay, how will you write it? This is 3 10, 4, 17, 6, 37, 8, 65. So these are the ordered pairs. Okay. Now they're asking whether this relation is a function or not. Yes, it is a function, because you can see that every element of X has got a unique element. Unique means it should be different. It should not be the same. Okay. Unique element in Y. So here it is. It is a function, and the domain is 3, 4, 6, 8. Codomain is 1, 2, 3, and the range is the set of images 10, 17, 37, 65. Question 3. Given the function f is from x to x square minus 5x plus 6, evaluate. Okay, so we have to find this value f at minus 1. This is very easy. The value of f at minus 1 is, you have to take this expression and put minus 1 in place of x. So it becomes f minus 1 is equal to minus 1 whole square minus 5 into minus 1 plus 6. So here in place of x minus 1, in place of x also minus 1. Now evaluate this. This becomes 1 plus 5 plus 6, that is 12. Similarly, in this sum, in place of x you have to put 2a here. Put 2a and evaluate, you will get the answer. Here you can put x as 2 and then solve this, you will get the answer as 0. Here you have to put another expression in place of x, that is x minus 1. So this full thing you have to put x minus 1. So here it is x minus 1 whole square, 5 into x minus 1 plus x. Open this, x square minus 2x plus 1. This is minus 5x plus 5 plus 6. Simplify this, you will get this answer. Question 4. A graph representing fx is given. In it, it is clear that f9 is equal to 2. Okay. So find the following values of the function. So here, so they have given us this graph. Okay. So here you can see f9 means the value of, this is the x-axis and this is the y-axis. So these are the y values, these are the x values. Or you can say y or fx, both are same. So this is x and this is fx. Okay. So here you can see that if the value of x is 9, the fx value will be 2. That is y value will be 2. You can see x is 9, y is 2. Okay. Now they are asking us to find f0. Let's take f0. That is, the x value should be 0. We know that the x value is 0 here at this point, origin. And look at the graph is touching here, y-axis at this point. So this is 9. f0 is 9. f7, where is 7 in the x-axis? Here it is. And then it touches the graph at this point. Okay, and if you take down this point, it is 6. f2, 2, x is 2. So go up like this, go to the graph, this, and here this is the point. So here is the y value or the f2 value, that is 6. f10, so here is 10, and here you can see that the y value is 0. So f10 is equal to 0. For what value of x is fx 1? So if you look at the graph, you will see that the fx value is 1. See, here it is. fx is 1 for this value. Okay. So you have to write it down as 9.5. Describe the following domain and range. So here domain is the x-axis, that is, you know, it is a set of real numbers, and here the values of x are between 0 and 10, including 0 and 10. So we will write it like this. And all these values of x are real numbers. Range is the y-axis, and the value of y is up to 9. It can be equal to 9 also. So 0 is equal to y is less than or equal to 9. Y belongs to real numbers. These are all real numbers. What is the image of 6 under f? The image of 6 under f is 5. That means this value of x is 6, and if you see, the value of f6 will be 5. Okay, question 5. Let fx is equal to 2x plus 5. If x is not equal to 0, then find the value of this expression. So let us write down fx is 2x plus 5. Let us find out f2. That means put the value of x as 2. Substitute here, you get 4 plus 5, 9. Now substitute x plus 2 in place of x. So fx plus 2 is equal to, put x plus 2 here. In the bracket, put it like this. Then open the bracket, 2x plus 4 plus 5, 2x plus 9. Now substitute these values in this expression. Write down the expression. Fx plus 2 is 2x plus 9. Write it down. Minus f2. f2 is 9. Write down 9. This will cancel. 2x upon x is equal to 2. This is the answer. Okay. So here we come to the end of this 5 sums. The rest of the sums of the same exercise, I have put it in a separate video. You can go through that also.